Hello, everyone. Welcome to another episode of Clay Loves Logic, where on this channel I solve logic-based Sudokus I find interesting. Today I'm going to be looking at the puzzle Cage Quivers by FullDeck and missing a few cards. Now, we're going to have standard Sudoku rules, standard arrows, and standard cages applying. I'm going to explain what that means, but as always, I'll put the link to this puzzle in the description of the video so you can try it out if you'd like. With that said, let's turn our attention to the rules. Well, normal Sudoku rules apply, so you have to have the digits 1 to 9 in every 3x3 box in every row, and of course in every column. Now we also have arrow rules, so digits along an arrow, sum to the value in the attached circle. So these two digits sum to whatever this is, these two 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 sum to whatever this is. And digits and cages cannot repeat and must sum to the value shown in the upper left corner of the cage. So these 4 digits sum to 4, which is where we're going to start because it's going to give us a whole bunch of stuff. First of all, there's only one way to make 10 using 4 digits, and it's 1, 2, 3, and 4, of which this has to be the 4 because it can't be. Oh, sorry. Could be a 3. This is 3 or 4, and then this is 1, 2, or this is 1, 3. But what I can tell you is the 1 is never there. Oh, and then this is a 1, 2, 3 triple, so this is 4. And then this is 2, and then this is 1 and 3. Good start. And a 10 cage with, oh, well, it has to have the same setup, doesn't it? Because, again, this can be 3 or 4. This can be 1, 2, 3. And then this is 3 or 4, because, again, there's always a 1 on this. So it's either 1, 3, or 1, 3 or 1, 2. Oh, did I do that wrong then? Could this have been... I think I jumped the gun on that. Let me just revisit this quickly. Because I said this has to be 2, 3, but that's actually not the case. It could be 2, 3, or 4, couldn't it? Because how would it look if this was 3? This would be 1, 2. This could be 4. Yeah, that's a totally fine composition. That works. So the point to note here is that this is either 3 or 4. This is 1, 2, or 3, and this is 2, 3, or 4. And everywhere we see a 10 cage, we're going to have that same setup. 3, 4, 1, 2, 3, 2, 3, 4. So now the question with some of these bigger cages is going to be basically thinking about it in a mathematical sense where we have X and then we have X as well, right? Because these two digits sum to this digit. So we have 2X plus Y equals 26. So then we have to think about what X can be. 12 could be 12 because that would be 12, 24, and 2. And how do you... Oh, no, of course it couldn't. Like, can't put 12 in the total of the... That's this... Can't put 12 here. It's at most 9. 9, 18. And then you still have to get to 8. That's what it has to be. Right? There's no other way to do that. 9 plus 9. 9 plus 9 is 18. Plus 8 is 26. So anywhere you see that set up, it has to be 9 and 8. 9 and 8. 9 and 8. And then 9 and 8. And then some combination of digits will get us summing to 9. Doesn't matter how. We can figure that out later. So that takes care of the 26 cages. What about a 22 cage? 9 could still... Well, you know what? Why don't we think about where our 9s can go? Because we can see now there's obviously a 9 somewhere over here. It can't be here because you can't put a 9 on an arrow unless it's at the end of the arrow. There's 9 somewhere here, and again, it could only be in 2 places. Oh, but 9 plus 9 is 18, which is bigger than 16. So the 9 is here. And now we know that none of those are a 9. So the 9 is somewhere down here. And then in this box, where do you put the 9? In this one. We don't put it here or here. And then 9 plus 9 is 18. So it could just be here. This could be 9. So could this. But of course, this one could not be a 9. 7, 14. If this is a 9, what has to go here? 22 minus 9 is 13, which doesn't work. This is not a 9. Can't be. Right? Because that would be basically saying this is 9 and these things have to be 2x, and 2x is going to be an even number, isn't it? So this has to be an even number. Yeah, that's true. Yeah, that's true. That's true. This has to be an even number. So then there's only one spot where you can put a 9 in the middle, and it is here. So this is a 9. This is not a 9. Now, there's only a 9 in the bottom because, again, remember, 9's not there, nor is it there, and it's too big to be there, which means this is 9. This is not 9. So that makes this a 1 because, remember, this is an 18 cage. So 9 plus 9 is 18 plus 1 is 19. Sorry, it's a 19 cage. And that makes the 1 not here, which will start moving some things. We get a 1 here. Yeah, nice. Okay. What about the 22 cage? Because we can use the same. We know that this has to be even. What if it's 8? And in fact, 8 does have to go in one of two positions here. Oh, beautiful. Look at that. It's just 8 anyways. It doesn't matter. There's just so many digits looking. 8s are almost done, in fact. Well, not quite, but there was 4 8s looking at it. 9s have to be almost done. Almost, nearly. But now we know that this is 22 minus 8 is 14. 7, 14 plus 6. Yeah. So this is a 7. These two digits then have to equal 7. Lots of ways to do that. Let's think about a 16 cage that now at its biggest is 7. If it is 7, this is a 2. Seems fine. What's the smallest this could be then? 5, 10, 6, 4, 8. Oh, wow. It could be, well, it actually can't be a 4 because if it's a 4, this has to be 8, which it can't be. So this is bound to either 5, 6, or 7. And then so 5 plus 5 is 10. This would be 6. 6 plus 6 is 12. This would be 4. And then 7 plus 7 is 14. This would be 2. Those are our options. Hang on 1 second. Okay. Well, what shall we think about? Should we think about 8s? Well, yeah, we should. Because 8s are going to be somewhere over here. Oops, didn't mean to pencil that one. Right, because we can't have an 8 on a 5, 6, or 7, and we can't have an 8 where there's already an 8. So we get an 8 in one of two spots. There's an 8 here. So we have an 8 here in one of two spots. Can't be in the middle. In this box of the puzzle, we have a similar setup, don't we? Although now this time, this digit could be an 8. Well, let's think then. Not an 8 there, not an 8 there. Yeah, so now we have this kind of pattern happening for our remaining 8s. Okay, what about this cage? Well, it actually has to be 5 or higher because we have 1, 2, 3, 4 quadruple. So 5 plus 5 is 10. So this is only 2 or 4, and this is only 5 or 6. And then if it's 5, these have to be some pretty low digits, and we would have a quadruple of low digits here. This would be a 1, 2, 3, 4 quadruple. Oh, and we've placed a 1. So that's a 1. And that will fix a 1. Oh, the puzzle's broken. Because now we have to have a 1 here, but we already have. Isn't it? How is this not broken? It says it's good. How is this? Look. Oh my, because there's a 1 in the first box. Holy crap. I was like, where do you put a 1 in this box now? You can't put it here and you can't put it on here. The 1 goes in here. That is so silly. My God. Oh, wow, that's funny. Oh my goodness. Geez, sorry about that, everybody. My goodness. What a day it's been. Oh, that's classic. It's actually very, very funny. Ah, look at that. Ones don't go up here, ones don't go there. We have 2 spots we can put a 1. And then in here, well, actually, that's beautiful, isn't it? Because look, where do you put a 1 in this box? Well, you don't put it on a 9 because you need it to be 1, 8. And there's already a 1 in this row. So, and it's not here because we have a 1, 2, 3, 4 quadruple. So again, this is a 1. And that gives us a 1 there. And now we'll have a 1 in one of 2 spots. In this box, though, it should be, yeah, it's the exact same thing. That's now a 1. That makes this a 1. This is not a 1. And our 1s have to be basically done, don't they? Yeah, because now, in fact, this is a 1, and this is a 6. And then that makes this a 1. So the second that this is a 1, for this to be 5, we need a 4 here. For this to be 6, we need a 5 here. So where do you put a 7? Only here. And then this is, 2, 3, 4, 5, or 6. Oh, look at that. You can't put a 6 here. You can't put a 6 anywhere else. So you get a 6, you get a 5. That's 12. This is therefore then 2. This is 3. That makes 4. So this is 2. This needs to be, well, this is 2 now because there's already a 2 here. So that makes this 3. That makes this 4. This is then, 1, 2, 3. This is then a 5. This is a fun puzzle. Quick. Okay, how do you make 9? We need 1 low digit, and it's just 3, 6. That's all it can be. Because it can't be 2, 7. It can't be 4, 5. It can't be anything else. It's just 3, 6. So this is going to be 1, 2, 4, and 9. This is a naked single then. What is it? 1, 2, 3. This is 4, 5, 6. This is 7. Up here, we're going to need 3. Nope, sorry. This is a 3, 6 pair. 1, 2, 3, 4, which is here. Makes this a 3, makes this a 2, makes this a 4. This is not 4 anymore. As soon as this isn't 4, what does that mean? This isn't 5? This is a 5, though, isn't it? That's true. How do you make... Well, what do we still have to actually make here? This is a 3. So this is a 4. So this is a 2. We need to make 9. We can't use 3, 6. We can't use 1, 8. We can't use... Well, we just have to use 2, 7. It's a 2, 7 pair. So 2 now has to be here because this can't be a 2, 7 pair because there's a 2, 7 there. So this is a 2. Puts a 2 somewhere here. And in fact, again, how do we make 9? Can't be 1, 8. Could be 2, 7. Actually, could be... Oh, it can't be 3, 6. And it can't be 4, 5. So this is a 2, which gives us a 7. This is no longer a 2. This is now a 6. As soon as that's a 6, what does that mean? 6, 12. Oh, if this is 6, maybe that was an incorrect pencil mark. Let me think here. 6. So what does this have to be? 6, 12. Oh, this has to be 5, actually. Yeah. Now these have to sum to 5, and they have to be from 2 and 3. So this has to be 7. This has to be 2. How do you make 9 now? It has to be 4, 5, which will be in this position, 5 and 4. This is now a 2. This is a 3. Up here, we need an 8 and 6, 7. So this is a 7 because of that. This is an 8, so this is no longer an 8. 8 somewhere up here. These two digits are now, well, actually, you know what? We have a 4. We can do this 4, 9. We can do this 3, 6. Up here, we need 1, 2, 3, 4, 5. We need 6 and 7, of which 7 has to be here, 6 has to be here. Across the top row, we need 5 and 8, of which this is therefore 8. This is 5. Here we're going to need a 4, which is here. Here we're going to need 1, 2, 3, 4, 5, 6. Working our way down the bottom, we only need one more digit. It's 3, which makes this a 6, which makes this 1, 2, 3, 4, 5, I guess. Yeah. And then what? 1, 2, 3, 4, 5, 6, 7, and 8, of which this is a 7, this is an 8. Down here, not a 4, sorry, 1, 2, 3, 4, 5, a 6. Across here, an 8, which is only in one spot. This is no longer an 8. This is then 1, 2, 3, 4, 5. Here, what do we need? 1, 2. We need a 3 somewhere. It's got to be there. 2, 3, 4, and a 5 has to be here. We need 1, 2, 3. So we need a 4 somewhere in here. It's here. We need 1, 2, 3, 4, 5, and 6. Only here. So this is a 9, and this is a 7. 16 minutes, 40 seconds, 376 people have solved this in 3.6 days. I like this puzzle. This is a great puzzle. Thanks, everyone. I hope you enjoyed watching. Consider liking and subscribing if you haven't, and I will catch you on the next one.